Welcome. In this video, I will talk about change of variables in partial differentiation, and I will introduce you to the concept of Jacobian. And in Jacobian, there are important problems that I will be solving. Along with that, I will also talk about given any transformation, whether they are functionally related or not. I have planned to discuss about cylindrical coordinate system and a spherical polar coordinate system, which are very important, right? So let's start the video. But before that, I want to quickly talk about a very important concept, that is the differentiation of implicit function. Ideally, I could have discussed it in the last video, but since I missed, I am discussing it over here. So if f of xy is equal to c be an implicit relationship between x and y, then we have a very important result given by dy by dx is equal to minus del f by del x by del f by del y. So to understand this, let us recall the concept that we discussed in the previous video, that if we have f which is a function of two variables x and y, and if suppose x is a function of variable t and y is a function of variable t, then how do we write df by dt? We write df by dt as del f by del x and dx by dt plus del f by del y and dy by dt. In this, if I take suppose x is equal to or t is equal to x. Suppose I take t is equal to x in this expression. So this expression will become what? This expression will become df by dx is equal to del f by del x, and since I have taken t is equal to x, this will become dx by dx and plus del f by del y, and it will become dy by dx. So dx by dx is equal to 1. So basically what I am getting df by dx is equal to del f by del x plus del f by del y and into dy by dx. So suppose we have a relationship like this, f of xy is equal to c, then if I find df by dx, this will become what? This will become 0, right? Because if I differentiate, or let me write over here to avoid the confusion, if f of xy is equal to c, then df by dx will be equal to 0. So df by dx using this expression can be written as del f by del x plus del f by del y into dy by dx, and this is equal to 0. So if we simplify, what we get is this relationship, because dy by dx now can be written as minus del f by del x divided by del f by del y. So we use this concept to solve some problems. So here we have this problem, and I'm not going to remove this, so I'm going to solve it here using a different thing. So suppose we have to find a dy by dx, and this is the problem that is given. So how can we find a dy by dx? We don't have to do it separately. We already have done this kind of problem in your previous classes, but here I am using the concept of partial derivative. So to write a dy by dx, I will write minus and then the partial derivative of this with respect to x. So with respect to x, it will be like 3x square and plus 3 into 2 6x y square, and with respect to y, what I will get? I will get 6 x square y plus 3 y square. So this is the value of dy by dx. I hope you got it. In case, let me write it again for your better understanding. Dy by dx is equal to minus, I differentiate it again, so 3 x square, and with respect to x it will give me 6xy square, and with respect to y, if I differentiate partially, x cube will give you 0, y square will give you 2y, so it will be 6x square y plus 3y square. This is what I have got here. Okay. Now we have another problem that we can solve, and here it is given that u is equal to this, and there is an implicit relationship between x and y, and we have to find du by dx. So to find du by dx, first of all I am considering u as a function of x and y. So I will write del u by del x, and then dx by dx plus del u by del y, and then dy by dx. Okay, now dx by dx is equal to 1, we know that, and if I differentiate this partially with respect to x, I have to use the product formula. So first function is x, derivative of log xy is 1 by xy, and then xy with respect to x again will give you y, and plus second function, that is log xy, and derivative of x will give you 1. Dx by dx is already 1. What is del u by del y? With respect to y, x is a constant, and log xy will give me 1 by xy, and then xy again with respect to y will give me x, and here I will get dy by dx. So this x and this x is cancel, here this x and this x cancel, this y and this y cancel. So I will get 1 plus log xy and plus x by y dy by dx. Okay, now we have to find dy by dx. So we have the expression, that is x cube plus y cube plus 3xy is equal to 1, and this is an implicit relationship between x and y. So what is dy by dx? Using the previous result that I discussed, partial derivative with respect to x by partial derivative with respect to y with minus sign. So minus, if I differentiate it partially with respect to x, I will get 3x square, and here this will give me 0 and this will give me 3y, and if I differentiate it partially with respect to y, I will get 3y square, and then I will get 3x. So I can take 3 common and I can cancel, so I will get x square y, x square plus y, sorry, not y square, and x square plus y, and divided by y square plus x. Okay, so if I substitute in here, the final answer that I will get is du by dx is equal to 1 plus log xy and minus x into x square plus y by y into y square plus x. So this is what I will get as the answer. Okay, now moving ahead, I am going to talk about the change of variable, and here I will be doing the derivation, and it will be a time consuming process, so you need to have the patience. If you directly want to see the formula, you can just write the formula. I can write the formula also, but anyway, if I explain it, it will be easier for you to keep it in mind for a longer period of time. So suppose that f of xy is a function of two independent variables x and y, and x and y are function of two new independent variable u and v. So that we have seen earlier that it is given that f is dependent on x and y, and x and y is dependent on uv, and y is also dependent on uv, right? So by chain rule, what we can write, if I ask you what is del f by del u, so you will say it is del f by del x and then del x by del u plus del f by del y and then del y by del u. If I ask you what is del f by del v, so you will say it is del f by del x by del v plus del f by del y and del y by del v. This we already know. What is my aim? My aim is to write or express what? Del f by del x and del f by del y, both these in terms of del f by del u and del f by del v, in terms of del f by del u and del f by del v. I repeat it. what I have done, using chain rule, I have written del f by del u in terms of del f by del x and del f by del y, del f by del v in terms of del f by del x and del f by del y. Now I am changing my aim. I am trying to write del f by del x in terms of del f by del u and del f by del v. How to do that? That is my aim. To do that, I am going to use a very important concept, and that is the concept of Cramer's rule. In case if you are not familiar, I am quickly going to explain it to you. So suppose we have a system which is like a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So first we calculate something known as delta, and delta is the coefficient determinant of the coefficient matrix, that is a1 b1 a2 b2, right? Then we calculate something known as delta 1, and I am presuming here, I am not going into the detail that solution will exist, not exist. I am assuming that solution is there. Then to get the value of x, first we calculate delta 1. And how do I calculate delta 1? I replace the first column by the right hand side. So the first column becomes c1 c2, and the right hand column, the second column remains same. And then I calculate delta 2 to evaluate the value of y. And you are smart enough to guess that here I will replace the second column by the right hand side, that is c1 c2. So what is the value of x? The value of x is given by delta 1 divided by delta, and the value of y is given by delta 2 divided by delta. So here in this problem also I am going to solve it. To solve it for what? To solve it to get the value of del f by del x and to get the value of del f by del y. So these are our variables, these are x and y. These are our variables that I want to get, right? And these are our right hand side, that is del f by del u, del f by del v. So I am going to use this Cramer's rule to evaluate this. So let us move to the next page. So here we have the situation. I have just copied the expression from the previous page, and this term which were appearing here in the left, I have written it in the right so that it looks in the suitable form. And what is my aim? My aim is to solve it for del f by del x. So I want to solve it for del f by del x, and I want to solve it for del f by del y, and I want it to write in terms of del f by del u and del f by del v as per our aim. So first of all, in the Cramer's rule, we have to calculate the delta. So how to calculate the delta? Delta is calculated using the coefficient. So I write here del x by del u, and here I write del x by del v, and then the second coefficient is del y by del u, and here we have del y by del v. And I hope you will not mind if I change the rows and column, because this is the property of a determinant, that if you change the rows and column, the value of the determinant does not change. So this becomes del x by del u, and the first row column becomes the first row, so del x by del v. And be mindful, I am writing u and v. Sometimes when I write quickly it becomes similar. So del y by del u and del y by del v. So this is what I have got. So this expression that I have got in this context is represented by this notation, del of x comma y by del of u comma v. And you see how it has been written. There are two rows here, and in the first row the first term, that is x, here is coming, and in the second row I am differentiating y. So I am writing x and y, which I am differentiating with respect to u and v. So u and v is coming into the denominator here, and x and y is coming into the numerator. So basically this expression that I have written is just another way of a representation of this determinant value. And this thing that I have got is known as the Jacobian J of transformation of xy in uv variable, right? So this I will be calling J. Now I am writing delta 1. So how will you write delta 1? Your first column here is replaced by the right hand side. So what is the right hand side? Right hand side is del f by del u and del f by del v, and the second column remains same, that is del y by del u and del y by del v. And for our convenience, again I can use the same idea that I can change the rows into columns, and you might be thinking that what is the need to change rows into column, because I want to use this notation so that it is easier for us to remember. It will be clear to you once you I will complete this. So if I change it, the first column becomes the first row, so that is del f by del u and del f by del v and del y by del u and del y by del v. And this expression, using the same definition here, if I use this notation, it will be represented as, so I have f in the first term, right? So I am writing f in the numerator, and then the y in the second row, so I am writing fy, and I am differentiating f and y with respect to u and v, so I am writing u and v. So this is our delta 1, right? And I wanted to solve it for getting del f by del x. So what will be del f by del x? So del f by del x now will become delta 1 by delta. So delta value I have got is in this context is Jacobian, that is 1 by j, and then this delta 1 is del of fy by del of u v. So this is what I have got. Now following the same set of arguments, so this is the first result that I got. So del f by del x is 1 by j del of fy by del of uv. How I will calculate delta 2? So delta 2, I hope you can easily calculate that here the first row, that is del x by del u, so I am writing del x by del u and del x by del v, which remains same, and the second column in the delta is replaced by the right hand side. So right hand side is del f by del u and del f by del v. So again the same logic, I am going to replace the rows and columns. So the first row becomes the first column, or first column becomes the first row. So I write del x by del u, del x by del v, del f by del u, del f by del v, right? So in the notation that I have used here, what I can write? I can write del. We are differentiating x and f, so I am writing del of x and f divided by del of u and v. So since I don't want to go to the next page so that everything appears on this, I am using the things here. So this is our delta 2. So what is del f by del y? If I can use this space here. So del f by del y, as per the definition, is delta 2 by delta, right? So delta I am replacing using the term j, so I am writing j, and delta 2 I have got del of x comma f divided by del of u comma v. So I have got the first result, that is del f by del x is 1 by j, where j is the Jacobian, and del of fy by del of uv, and del f by del y is 1 by j del of xf by del of uv. How to remember it? So you see, 1 by j is same in both the cases. Del of uv, the denominator del of uv, is same in both the cases. When I am finding del f by del x, in the Jacobian, which is del xy, I am replacing x by f, and when I am finding del f by del y, I am replacing y by f. So it is very easy to remember. Del f by del x, everything remains same, 1 by j del of fy by del of uv, 1 by j del of xf by del of uv. Only change is this expression, this. So if you just remember the way Jacobian is calculated. So in Jacobian, in the numerator, in place of x, you are replacing it by f, and in place of in case of del f by del y, in place of y, you are replacing it by f. So I'm going to write the whole thing in the next page again, so that you remember the main result. So I have expressed that is del f by del x is equal to 1 by j del uv, and here I am writing del of fy. And what is del f by del y? Del f by del y, I am writing 1 by j del of in place of y I am putting f, so del of xf by del of uv. And I think you are smart enough to understand that if you look at this term here del of xf, what I can do, I can even do the row exchange. So in determinant, if you do the row exchange, means if you change these two rows, what you get one extra minus sign. But if you change this row, the first row will become del f by del u and del f by del v, and second row will become del x by del u and del x by del v. So this expression will become del of fx by del of uv. So basically what I can write, I will write it 1 by minus j del of fx by del of uv. I hope you have understood it. That basically if you are changing the location here in the variable, what is happening? If you are writing del fx, del xf means what? First row you will write del x by del u and del x by del v, and second row you will write del f by del u and del f by del v. But if you do the row exchange, there will be a minus sign, because in determinant one row exchange results into a minus sign, and the first row will become now del f by del u, del f by del v. So you write it del of fx by del of uv. So either you write this or this, both the cases remains same. So this is the first result that I have established. This idea can be extended to any number of variable. So I am going to quickly write it for 3 variables. So suppose we have a function f which is dependent on 3 variables, that is x, y and z, and x is dependent on 3 variables u, v and w. Y is also dependent on 3 variables u, v and w, and z is dependent on 3 variables, that is u, v and w. So what do you think it will be? What will be the Jacobian of transformation, by the way? So suppose I have this relation that x is a function of, let me call this a small f so that I can use capital F for them. So let me call this a small f of x, y, z, and f is a function of u, v and w. Y is also a function, let me call another function g, u, v and w, and z is a function of 3 variables, let me call it h, that is u, v and w. And what I want to write del f by del x, I want to write del f by del y, and I want to write del f by del z. So for that, what I have to do, I have to write 1 by j Jacobian of transformation, and I think you are smart enough that it will be what? It will be del of, and when you are differentiating it with respect to x partially, in place of x you will write f, and here you will get y and z divided by del of u, v and w. This will be what? This will be 1 by j, and del of, in place of y you will write f, in place of z it will remain z, and divided by del of u, v and w, and this will be 1 by j and del of x, y, f by del of u, v and w. Again, if you want to leave it like this, fine, but if you want to do the row exchange, here the first and second row can be exchanged, so it can be written as minus 1 by j del of f, x and z by del of u, v and w. And here you notice that first, to get f in the first place, you have to do the row exchange, first, second and third. So here you will get x, f and y, and then you do the row exchange one more time, so you will get 1 by j and del. So there will be two minus sign that will come out, so that minus minus will become plus, so it will become del of f x y divided by del of u v and w. And I also believe that you are clear about what does this j represents. So first of all, in three variable, if I write the Jacobian of transformation, that will be j is equal to del of x y z by del of u v and w. So as per the property, this can be written as del x by del u, del x by del v and del x by del w. So first I fixed x and then differentiated partially with respect to u, v and w. Then I will fix to y, del y by del u, del y by del v and del y by del w, right? And then with respect to j, then I will fix z and I will write del z by del x, del z by not x, del z by del u. See, don't make the mistake, del z by del u, del z by del v and del z by del w. So this is how you define the Jacobian, and rest of the terms you can define. So if you have to write this term, this expression, only thing is that everything will remain same. In the first row, in place of del x, del x, del x, it will become del f by del u, del f by del v, del f by del z, del w. So I am going to solve problems where I will be using this transformation so that it will be more clear to you. So let us take this example now. I have one transformation from Cartesian to polar, which I can write as x is equal to r cos theta and y is equal to r sin theta. This is a very popular transformation, you might be aware. So suppose I have to find the Jacobian of transformation from xy system to r theta system, right? So this is how it will be defined. I will find j is equal to del of xy by del of r theta. So as per the definition of this term, I can write del x by del r and del x by del theta. Then I take the y term and I write del y by del r and del y by del theta. Okay, and then if we solve it, what will I get? So del x by del r, so x is equal to r cos theta, so del x by del r will be just cos theta, and del x by del theta, so the derivative of cos theta is minus sin theta, r is a constant, so it will be minus r sin theta. And if I talk about del y by del r, so here it will be just sin theta, and del y by del theta, so it will be r cos theta. Okay, so let us solve it. So cross multiplication, you know how to expand the determinant, so it will be r cos square theta and minus minus plus r sin square theta. So r can be taken common, and in the bracket you will get cos square theta plus sin square theta, so the value of this will be equal to r. So the Jacobian of transformation from xy to r theta, if I have to transform xy system to r theta system, the Jacobian of transformation will be r. So this is a very important result, and you have to remember this, because a lot of times they have asked this question, that if we have this transformation, then what is the Jacobian value? But one important property of Jacobian that I want to highlight. So suppose I ask you that, what if I ask you the Jacobian of transformation from r theta, del of r theta to del of xy. So if I want to transform r theta system into xy system, then we have to use this Jacobian of transformation. So to use it, first of all, you know that we have to define it like del r by del x, because I am fixing r first and differentiating it with respect to x and y. So here I will have del r by del y, and then I will have del theta by del x and del theta by del y. But before I do this calculation, we need to write this r and theta in terms of x and y. So we know that this is the relation between xy and r theta. So it is very obvious that r can be written as under root x square plus y square. Because if you take the square of it, you will get x square plus y square is equal to r square. So r is this, and theta can be written as what? So if you divide divide y by x, you will get tan theta. So theta will be tan inverse y by x. I hope this part is clear to you. Now if I have to evaluate del r by del x, then what it will be? It will be 1 by 2 times under root x square plus y square, and then with respect to x, so it will be 2x, and if I differentiate it with respect to y, I will get 1 by 2 under root x square plus y square into 2y. Theta, if I differentiate it with respect to x, I will get 1 by 1 plus y square by x square, and the derivative of y by x with respect to x will give me minus y by x square. And the second term sorry, and the second term that I will get del theta by del y, so it will be 1 by 1 plus y square by x square, and with respect to y here, if I take 1 by x outside, so del y by del y will become 1, so I will get just 1, right? Now we have to simplify this, so this 2 and this 2 is cancelled, this 2 and this 2 is cancelled. So I have to move to the next page. So what I am going to do, I am going to write it over here. So this is what I will get. I have already written it. So you just verify that it is okay. So here first row is x by under root x square plus y square and y by under root x square plus y square. And if you simplify this, you will get x square plus y square, and in the numerator x square will go. This x square here in the numerator will cancel this x square. So you will get minus y by under x square plus y square. And here also in the second term, you will get x square. So this x and x will cancel. So you will get x by x square plus y square. So if you simplify, what you will get? You have to do this multiplication. So you will get x square and by x square plus y square into under root x square plus y square. And if you multiply this, you will have minus minus plus. So you will get plus y square by x square plus y square and under root x square plus y square. So if you add this, it is very obvious that denominator are same, so numerator will be added. So you will get x square plus y square, and in the denominator you have x square plus y square under root x square plus y square. So this term here, x square plus y square, and this term is cancelled. So I get 1 by under root x square plus y square, and this is nothing but, as you have seen, that r is equal to under root x square plus y square. So what I have got is 1 by r. So we have just shown one very important property, that if I was calling j as del of xy by del of r theta, and if I call this quantity as j dash, so we have the property that j into j dash is equal to 1, because the Jacobian of transformation del xy by del r theta was r, and the Jacobian of transformation del r theta by del xy is equal to 1 by r. So this is true in general. I have shown you with the help of this example. Another property of Jacobian that I want to talk about, that suppose we have two variables x and y, and suppose x and y are dependent on the variable like u and v, and y is also dependent on the variable like u and v, and suppose u is further dependent on the variable like r and s, and v is also dependent on r and s, and same is true with this u and v also. So here u and v are the functions of r and s, and suppose I want to find the Jacobian of transformation del xy by del rs. Okay, so to find this Jacobian of transformation, what we can do, we can write del xy by del uv, kind of same thing, that first xy with respect to uv I find the Jacobian of transformation, and then with respect to del uv by del rs. So this is kind of you have seen earlier the chain rule kind of thing. So here we are doing the same thing, that if we have to find the Jacobian of transformation uh, for del xy by del rs. So first we are calculating the Jacobian of transformation from del xy by del uv and then del uv by del rs. So these are two very important properties of Jacobian. Okay, let's solve this problem quickly. So this will use the concept of Jacobian of transformation. So here you can see that it is given that z is a function of x and y, and x is a function of r cos, r and theta, and y is a function of r and theta, that is x is equal to r cos theta, y is equal to r sin theta. And we have to prove that del f by del x whole square plus del f by del y, sorry, it should be y. So del f by del y whole square is equal to del f by del r whole square plus 1 by r square del f by del theta whole square. So this is a result that I have to prove. So there are two ways to prove this result. First of all, you can find del f by del r and del f by del theta using the chain rule of differentiation, and then you can substitute and get this value. But I want to solve it using the Jacobian of transformation. So we just have seen that if I want to write del f by del x in terms of del f by del r and del f by del theta, this is what I was explaining here. So let me show you the main result which I just discussed so that you get the context. So here I have the situation where f was dependent on x and y, and x was dependent on u and v, and y was dependent on u and v. So I have shown you that how to write del f by del x in terms of del f by del u and del f by del v, and for that we already have got our formula. So this formula I already have got. Del f by del x, please note it down, is 1 by j del f y by del u v, and del f by del y is minus 1 by j del of fx by del of uv. So I have to use this concept which I hope you have got, right? So I have to write del f by del x, so it will be like 1 by j and del of fy by del of r theta. I hope it is clear to you that here f is dependent on x and y, and x is dependent on r and theta, and y is dependent on r and theta. So I can write del f by del r using the chain rule, but now I want to write del f by del x in terms of del f by del r and del f by del theta. Pause the video, think about it. Now 1 by j in the previous slide I already have calculated, so I am not going to repeat the same thing. If I use this transformation, x is equal to r cos theta, y is equal to r sin theta, this Jacobian value I get is r, which I already have got, so I am not going to do it again. So I get 1 by r, and what is this del f by del y and del r by del fy by del r theta. So that will be equal to del f by with respect to r, and then del f with respect to theta, and then del y with respect to r, and del y with respect to theta. I hope you got this. Now this expression can be written like what? This expression can be written as 1 by r, and I don't know what is the function f of xy, so I can't do anything with this. So I just write it as such, del f by del r and del f by del theta. And what is del y by del r? Y is equal to r sin theta, so del y by del r is equal to sin theta. And what is del y by del theta? This is equal to r cos theta. So if I simplify it, I will get 1 by r, and here I do the cross multiplication, so r cos theta into del f by del r, and here I get minus sin theta into del f by del theta. Okay, so this is what I have got is del f by del x. And similarly, if I ask you what is the value of del f by del y, so del f by del y is equal to 1 by j, so I am writing it directly this time. So 1 by j is 1 by r, and here if you want to write it or let me write otherwise, some of you may get confused, because you are doing the first problem. So del a by del y is 1 by j del you know what we have to do in place of y we have to put f. So I write x in place of y we have to put f by del of r theta. Now I am writing, so 1 by j is equal to 1 by r, and here I will write del x by del r because x is coming first, and then del x by del theta, and then in place of f, so I will write del f by del r and del f by del theta. So this will give me what? This will give me 1 by r, and x is like r cos theta, so I can write it minus r sin theta, and x is r cos theta, so not minus r sin theta. What I am doing, it looks like I am tired now. So del x by del r, so if I have to differentiate it with respect to r, I will get cos theta, and del x by del theta, so I will get minus r sin theta, and this term will remain as such, del f by del r and del f by del theta. So I now need to simplify it. So if I simplify, I will get 1 by r cos theta into del f by del theta, and minus minus plus, so it will become r sin theta into del f by del r. So this is the value of del f by del y, this is the value of del f by del y, and this is the value of del f by del x. Okay, so here I have written this expression. Just let me show you. I have written del f by del x is equal to, if I multiply it, I will get r cancel, so cos theta del f by del r, so I have written it here, cos theta del f by del r, and then you have a minus sin theta by r del f by del theta, so that is what I have written, minus sin theta by r del f by del theta. And if you look at the second expression, del f by del y, so if you multiply r here in the bracket, you will get cos theta by r del f by del theta plus sin theta del f by del r. So this is what I have written. And originally what I have to prove, that a square of this will add to this, so I just have to square and add. So squaring and adding both sides, we get what we get. So we get del f by del x whole square plus del f by del y whole square is equal to, here we get cos square theta del f by del r square, and here I get sin square theta del f by del r square, means a square plus b square, right? So let me write this, cos square theta plus sin square theta del f by del r whole square. So a square term of this and b square term of this, and then a square of this and plus a square of this. So I will get what? Sin square theta by r square and cos square theta by r square. So I will get 1 by r square sin square theta plus cos square theta, and in the bracket I will have del f by del theta whole square, and there will be two AB terms. So 2AB will be 2 cos theta sin theta by r del f by del r del f by del theta, and here also you will get 2 by r sin theta cos theta del f by del theta del f by del r. So they will cancel, so no need to write. This will become 1, this will become 1, so it will become del f by del r whole square plus 1 by r square del f by del theta whole square. I would strongly suggest you that don't believe me, do it on your own so that you understand that what I am trying to explain, right? So I have proved this result very handsomely, and up to this I hope there is no doubt. Moving ahead, we are already kind of 42 minutes in the video, but I want to complete lot of interesting thing here, so certainly the video is going to be slightly longer, so just be with me so that you don't miss anything, right? So let us look at this particular problem, that if u is equal to this, we have to prove this result. So it is given, and it is a very easy problem, that u is equal to, so what I am going to write, I am going to write u as a function of capital X, capital Y and capital Z, where capital X I am calling as a small x minus y, capital Y is a small y minus z, and capital Z as a small z minus x, right? And we have to prove this. So now I have to differentiate. So basically what is the situation here? This is a function of x, y and z, and this x, y and z can be treated as a function of x, y, a small x, y, z. This can be treated as a function of x small y, x, y, z, and this can be treated as a function of a small x, y and z. You may argue that sir, in x there is no z, but I can consider it x minus y plus 0 z kind of thing, right? So that it looks symmetrical. So if I have to find del u by del x using the chain rule, I can write it as del u by capital del x by a small del x, and then I hope you can get, I am writing del y by del x plus del u by capital Z del z by del x. So this will be equal to what? Del x by del x will give you 1, and del x del u by del x, and then del x by del x will give you 1, and here just give me a moment. Okay, so that's fine. So it is del u by del x I am writing, I am just explaining it this way, and del x by del x, so it will be like 1, so I just write 1 here, and here del y by del x, so there is no x in this, so this term will become 0, and in the last one we have del z by del x, so if I differentiate this with respect to x, I will get minus 1, so I will get here a del u by del capital Z and minus 1. Now how to find del u by del y? So again I will write del u by del capital X by del y, and rest of the term, I hope you got this chain rule, del u by del z and then del z by del y. So del u by del x and del x by del y, so from here I will get del u by del x and del x by del y, so I will get minus 1, and plus del y by del y, so I will get del u by del y, and from here I will get plus 1, and the del z by del y, so there is no y, so it will become 0, and finally I calculate del u by del z small. So del u by del capital X by del small z plus del u by del capital Y and del capital Y by del small z, and del u by del capital Z and del capital Z by del small z. This is the chain rule, and in case if you have difficulty in understanding this, you need to watch the previous video. So there will be, this term will become 0 because there is no z. Del u by del y, so I write it del u by del y, and del y by del z, so this will give me minus 1, and plus del u by del capital Z and del z by del z, this will give me plus 1. So in the left hand side, what we have to do, we have to add the left hand side, so I'm going to add. So adding the left hand side, I will get del u by del x plus del u by del y plus del u by del z. So what I will get, so if I add it, you can see del u by del x, so this term and this term will cancel, del u by del z with a minus sign and del u by del z with a plus sign, so this term and this term is cancelled, and del u by del y plus del u by del y minus, so this will cancel, so what I will get is 0, and this proves the result. So this is another interesting problem. Just check it carefully and let me know in case you have any doubt in the comment section. Okay, so now there is a problem, simple problem, just related to finding the Jacobian of transformation. So here we have u, v and w. So Jacobian of transformation means we have to calculate J, that is del of u v w, and u v w are dependent on x, y and z, so I will calculate del of x, y and z. So we already have explained in detail, so this will be written as del u by del x, del u by del y, del u by yeah, correct. First I fix u and then I differentiate it with respect to x, y, z, and then I fixed v, so del v by del x, right, and then del v by del y and del v by del z, and then I fix w, so del w by del x, del w by del y and del w by del z. So actually I have written this for your convenience, otherwise I could have written this directly also, right, but anyway, it is important to understand. So now let me evaluate this value. So del u by del x, if I differentiate this with respect to x, I will get 1, with respect to y I will get -1, with respect to z I will get 1. V x plus y minus z, so I will get 1, 1 and -1, so 1, 1 and -1. Now if I differentiate w with respect to x, so I will get 2x plus z minus y. With respect to y I will get minus x, and with respect to z I will get x. Okay, so now if I evaluate this determinant, we just can add like first two rows. So if I add the first two rows, or I add this and this row, so I will get what? I will get 2 0 0 1 1 minus 1 and 2x plus z minus y minus x and x, right, and then I expand it about the first row, so 2 times 1 into x is x, and minus x into -1 is also x, so x, then rest of the term will become 0, so this is 2 into 0, so that is equal to 0. So that is the value of Jacobian of transformation. Okay, now this is one of the main results that I wanted to discuss, and where I'll be using this in the next unit in the multiple integral. So what happens, there is something known as a rectangular coordinate system, right, and that is represent in 3 dimension. Any point in rectangular coordinate system is represented by x, y and z. But there is something known as cylindrical coordinate system, right. So you just can see this picture. In cylindrical coordinate system, any points x, y, z is represented by r, theta and z. So the z variable remains same, x, y is changed into r and theta. So suppose this is a point in the space, so how do you locate this point? You know that in x direction you move x axis, in x axis you move x distance, in y direction you move y distance, and in z direction you move z distance. But here this r theta is related to x and y. So how? So from this point you drop a perpendicular in xy plane. You can see this is the point, and from this point you have dropped the perpendicular. So this is the foot of the perpendicular of this point in xy plane, and now you join this point to origin. So this distance that you get is equal to r, and this angle, which line, the foot of the perpendicular, if I call this point P and this point M, so M point is lying just vertically below the point P. So this distance will of course be z, because this is how you measure the distance z, that its distance from the xy plane. So this distance is z, this distance is r, and this angle which this line is making with x-axis is theta. So if I have to change the Cartesian coordinate system into rectangular coordinate system, and this is a very important thing, you have to remember this. So how this transformation will happen? So of course z is equal to z, there is no doubt about that. Now you can clearly see that if this is r, and if I take its projection in the direction of this x-axis, this angle is theta, so x will be nothing but r cos theta. And what will be y? So if I take its projection in the direction of y-axis, this distance will be r sin theta. So this is the relationship between a rectangular coordinate system and cylindrical coordinate system, right? So xyz is changed into r, theta and z, where r is the distance of the foot of the perpendicular of the point from the origin, and theta is the angle that this line which is joining the foot of the perpendicular to origin is making with x-axis. The angle is being made with the x-axis, right? So if they ask you that calculate the Jacobian of transformation, that if I have to change x, y, z coordinate system into r, theta and z coordinate system, so what will be the Jacobian of transformation? So I am not going to write the formula which I already have written in the previous problem, right? So I am directly going to write the derivatives. So first we fix the variable, and then we differentiate it with respect to r, theta and z. So if I differentiate r cos theta with respect to r, I will get cos theta. With respect to theta, I will get minus r sin theta. With respect to z, I will get 0, right? Now if I fix y, means r sin theta, and I have to differentiate it with r, z, theta and z. So with respect to r, I will get sin theta. With respect to theta, I will get r cos theta, and with respect to z, I will get what? 0. And then with respect to z, so del x by del z will be 0. Then y with respect to z, 0, and z with respect to z is equal to 1. So if you expand this about the third column or third row, so I just 0 into anything will become 0, 0 into anything will become 0, and this will be 1 times r cos square theta plus r sine square theta. So what I get is equal to r. So this is an important result, very popular. So you have to keep in mind, this is something that you have to keep in mind, that Jacobian of transformation that I already have written here is equal to r, where this distance is equal to r. Okay, moving ahead, another important transformation is transforming the Cartesian or rectangular coordinate system into a spherical polar coordinate system. So here it is slightly more technical. So here this point which is there in the space is the point x comma y comma z, and there is a scope of confusion here in terms of notation. Some people use this rho r distance as rho, so be careful about that, which notation is being used. There is more confusion in this expression. Why it is more confusion? Because some people take this angle as phi and this angle is theta. So you need to be careful that which angle is theta and which angle is phi. But before that, let us understand. So if you look at this point which is xyz, and it is being changed into the point r, theta and phi. So how it is being changed? From this point we are dropping a perpendicular in xy plane. So this is the foot of the perpendicular from this point on xy plane, and then this point is joined to origin. So this line which is the foot of the perpendicular of the point P, so point P is in a space. From point P I have dropped a perpendicular in the xy plane. Now this point is being joined to origin, and this angle is being called as theta. Now this point is directly also joined to origin, and it is making an angle of phi with z axis. So now what will be the relation between x, y, z and r, theta and phi? And this is something that you have to remember. And I also want to highlight this, that some author take this as phi, this as theta. So you need to be very clear that which angle you are taking theta or which angle you are taking as phi. So this distance is r, so I am going to follow this convention. So if this distance is r, first of all, if I take the projection of this line, let me call this origin, so OP line in the z direction, so projection of this will be the coordinate of z. So if this is r and this is phi, then z value will be r cos phi, and its projection in xy plane. So this I hope you can clearly see that this angle is 90-degree angle, right? So if this is r cos phi, this line, that is OM, this line is r sin phi, right? So r sin phi. Now this distance from O to M is r sine phi, and if this angle is theta, so if I take its projection in the direction of x, it will be r sine phi into cos theta. And if I take the projection of this in the direction of y, it will be r sine phi into sine theta. I repeat the whole thing one more time so that you do not get confused, because if you have arrived till here, I hope you are a very sincere person, because usually people don't watch the video till the very end. But these things are important to understand, so that is why I have taken more time. So the idea that I want to highlight here is that we have a point in the space whose coordinates is x comma y comma z, right? And I want to change it into a spherical polar coordinate. So in a spherical polar coordinate, any point is represented in terms of r, theta and phi. Now what is the notation r here? So r is the distance of this point from the origin. So I joined this line, and this distance that I have got is r. And what is theta? So from this point I dropped a perpendicular in xy plane, and then I joined this origin to this point, and the line that this line is making an angle theta. So this angle is theta, and this point, this line OP is making also an angle with z axis. That angle is phi. So what is z? Z is equal to r cos phi, and if this is r cos phi, then this point, if I call it O and this as M, so the distance OM will be equal to r sine phi. I hope you understand the projection. Now if this is r sine phi, then this in x direction, the component of OM in x direction will be r sine phi into cos theta, and component of OM or projection of OM in the y direction will be r sine theta, r sine phi into sine theta, because this angle is theta. So this will be like r sine phi into sine theta. Now I have a homework problem for you. The homework problem is that you have to calculate J, that is Jacobian of transformation, from xyz to r, theta and phi. If you have understood this, already you have mastered lot of different concepts. Now before I wind up this lecture, I want to talk about something known as functional relation. So the variable of transformation, suppose we have three transformation. So we have u, v and w, and u, v and w are dependent on x, y and z. So that is what it is written, that the variable of transformation which I am giving by u is equal to a function of x, y, z, v is a function of x, y, z, w is a function of x, y, z. They are said to be functionally related if the Jacobian of transformation del u v w by del x, y, z is equal to 0. If this is equal to 0, it means that there exists a relationship between u, v and w, and the transformation is not independent. Means u, v and w are related, they are not independent, right? I hope you have come across this kind of concept in the rank of the matrix, in the Wronskian also. So whenever it is 0, you say it is dependent. So here the Jacobian is becoming 0, so you are saying that these variables u, v and w are dependent. So to understand it, we have a problem here, that check whether the transformation given is functionally related, and if so, means if they are functionally related, we also have to find the relationship between them. So how to find that? So we first define the Jacobian of transformation, that is u, v, w divided by del of x, y and z. It is not divided, it is just an expression, but I hope you have understood. I am not writing the detail, I am directly writing the determinant. So I have to fix u and I have to differentiate it with respect to x, y and z. So x square 2x minus y square, it will be minus 2y, and minus z square, it will be minus 2z. Then v with respect to x, y and z. So with respect to x square 2x, with respect to y minus 2y, and with respect to z, so it is z square, it is a small z, sorry, so z square, so it will be 2z. And then w with respect to x, so it will be like 4x cube, and from here I will get minus 4xy square. With respect to y, 4y cube and minus 4xy square, right? And with respect to z, I will get 4z cube. I hope it is clear. 4x cube minus 4xy square, 4y cube minus 4 y cube. Sorry, here I have made a mistake. It is like that is why I was checking. So if I differentiate it with respect to y, so I will 4x square will be 2x square will be constant, so it will be 4x square y, and then 4z cube. Now I have to expand this determinant. So what I do, for our simplicity, I add the row 2 to row 1. So I will get 4x, then adding will be easier or subtracting will be easier. So it is 2x, it is minus 2y, it is 2z, right? So just give me a moment. So it is subtraction basically, because I was slightly worried that what I am doing. So I have subtract, so I will write 2x minus 2y and minus 2z, and if I subtract, it will become 2x minus 2x 0, minus 2y minus minus 2y will become 0, and 2z and minus minus 2z, it will become 4z. And then we have 4x cube minus 4xy square, we have 4y cube minus 4x square y, and then we have 4z cube. So I can expand it about the second row. So plus minus plus minus plus minus, so I will get minus 4z. I hope you understood what I did. So if I start here, we change the sign alternatively, plus minus plus minus plus minus. So 0 into anything will be gone. I just take minus 4z. So this row is gone, this column is gone. So 2x into this. So 2x into this. So I will get 8 xy cube, and 2x into this minus 8 x cube y. Okay, and then this gone, this gone, right? So this into this, now this into this, so this will be plus minus 2y, and this will be plus. So 4 into 2, 8 x cube y, and it will be minus 8x y cube. So what will I get? 8xy cube and 8xy cube and 8x cube y and 8x cube y. So that will become is equal to 0. So it means what? That they are functionally related. The question is, check whether the transformation is functionally related. So the answer is yes, they are functionally related. Now you might be thinking, what is the meaning of functionally related? So that I am going to explain, since we don't have a space and I don't want to move to the next page. By functionally related means that u, v and w are related with each other in terms of a function. And if you look at u and v and w, you realize that if you add u square plus v square, what will you get? I'm not going to write the detail. I hope you remember the formula, a plus b plus c whole square, right? So if you square it and if you square it and add, what you will get is equal to 2w. So I just leave for you to verify this, or can we just do it also, because some of you may get confused also, because so for that I have to move to the next page, right? How much time? Yeah, so let me move to the so here I have already written the relation. What I am saying, that take u square and plus v square, and see this Jacobian just gives you the idea that there is a functional relationship. What kind of relationship is there? That is something that you have to see and decide. So you have to use your own mind and hit and trial process to understand that this kind of relationship is there. But since the Jacobian is 0, we are certain that there exists a relationship between them. So here if I take u square, actually I have to square x square minus y square minus z square square, and plus v square, that is x square minus y square plus z square. So if I do this, I will get x to the power 4 a square plus b square plus c square plus 2ab, so this will give me minus 2x square y square plus 2bc, so this will give me plus 2y square z square, and 2ca, so this will give me minus 2z square x square. And if I add this, so I will get x to the power 4 plus y to the power 4 plus z to the power 4 and 2ab, so I'll get minus 2x square y square plus 2bc, so I will get minus 2y square z square and plus 2ca, so 2z square x square. So you can see that if I add this term and this term cancel, this term and this term is cancel. So we have x to the power 4, x to the power 4, so 2 times x to the power 4, y to the power 4, y to the power 4, so y to the power 4 plus z to the power 4 and minus 2x square y square. So we have got a relationship between them, that if you add u square plus v square, you get 2w. So this was known to us that there will be a relationship, and we have just verified also that this relationship is there, right? So this is all in this video. It was a very long video. If you have watched it till very end, I appreciate it. Thanks for watching and have a very great day.